Hello everyone, today we're going to be learning about dividing rational expressions. So to divide rational expressions, we can think of it as dividing fractions. And something that helps me with remembering how to divide fractions is the acronym KFC. And what that stands for is keep, flip, and change. So for example, if I had 3 over x squared divided by 2 over x, what this k means is I'm going to keep that first fraction. So I'm going to keep the 3 over x squared. I'm going to flip the second fraction. So instead of 2 over x, that's going to become x over 2. And then I'm going to change that division sign to be a multiplication sign. And so now this becomes just multiplying fractions. And so I multiply across and I get 3x over 2x squared. And then if I simplify that, I get 3 over 2x. And so that's what we're going to do when we are dividing these rational expressions. So let's go through these first two examples first. We're going to find the quotient, and then we're going to state any restrictions on the variable. So number one, I have the 16x cubed y squared over 6xy divided by ax to the fourth y squared over 3y cubed. So first for the k, I'm going to keep my first fraction. I'm going to flip my second fraction, so now the 3y cubed is going to be on top, and the 8x to the fourth y squared is going to be on the bottom. And I'm going to change that division to be multiplication. And then now I can multiply across. So 16 times 3, I get 48. And then x cubed, y squared times y cubed, I get y to the fifth, since I add those exponents. 6 times 8, I get 48. X times x to the fifth, or x to the fourth, I get x to the fifth. And then y times y squared, I get y cubed. So looking at this, I immediately see I have a 48 on top and I have a 48 on bottom, so those cancel each other out. Then x cubed divided by x to the fifth, I get an x squared, and that x squared is going to be on the bottom because that is where the larger exponent was. And then y to the fifth divided by y cubed, I get y squared. And then I need to state any restrictions. So looking at the very beginning, I have an x and y in the denominator, so that means that x cannot equal 0 and y cannot equal 0. Okay, let's look at another one. So here I have 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. So first step is I'm going to keep my first fraction. I'm going to flip the second fraction. And then I'm going to change that division to be multiplication. And now we're going to go through the same steps that we did with multiplying these rational expressions. I'm going to factor all of the numerators and denominators. This first one can't be factored any further, so I just have 7x over 2x minus 10. Here, the top, x squared minus 11x plus 30, that can be factored to be x minus 5 times x minus 6. And then the bottom here, x squared minus 6x, that can be factored to be x times x minus 6, since I factor out that GCF of x minus 6. And then now we can go ahead and multiply. Oh, but here I actually missed one that can be factored. This 2x minus 10 does have a GCF of 2. And so when I factor that out, I have 2 times x minus 5. And so multiplying across, I get 7x, x minus 5, x minus 6, over 2x, x minus 5, times x minus 6. And so looking to see what cancels out, I see I have an x on top and bottom that can cancel out x minus 5 and x minus 6. So this, I actually end up with just 7 halves. And then looking to see what my restrictions are, I see in the denominator here at x can't be 0, x can't be 6, and 5. So all of those values, if I were to plug it back in, would make the denominator equal to 0.